Hello all you crazy people out there, my name is Michael, I like wizards and dragons and making games, and welcome back to 3D Collisions in GameMaker. So this is the moment of truth, this is the day that we're going to figure out how well exactly all of the collision hierarchy and triangle collision code that we wrote over the past, I don't even know how many videos anymore, how well that's going to work in an actual game. So I'm going to take the 3D Collisions project that we've been working on, and I'm going to go, once again, tools, create local package. Publisher name can just be Drago. Display name can be, I'm gonna call it collisions test. I guess the version can be like 1.1 or something because this is Act 2 as I've been calling it. The package ID and or file name can also be collisions test, and the actual project assets that I want to export are going to be just everything that was in the collision stuff folder. All right. So we can save that. We can save that over whatever's already there. Open that in Explorer so that we can just drag it into GameMaker later. And let's actually open up the 3D collision test world. So this project is mostly the same as it was the last I left off. I've made a few changes. One is that now, instead of how many trees were there before, instead of down here, instead of 250 test tree objects in this 3D world, there's now 1,000, and that is much more computationally expensive than it was than it was last we left off. Also, I've added a little, when you click the left mouse button, there's a little raycast ball that goes and flies off into the distance. That is going to be used for testing raycasts soon enough. Right now it doesn't do anything. Okay. And in addition to that, I've made some changes to the way that things are drawn so that drawing is a little bit more efficient, and so that the debug timings that we're seeing actually are mostly to do with how well collisions perform. And I've also made some changes to the way that drawing things are done, so that drawing is a little bit more efficient. Drawing things in 3D space is a little bit more efficient. And any lag that we see by way of the debug timers in the game will have more to do with actual collision code, more so than it'll have to do with actually drawing stuff, which is often what the bottleneck in 3D games is. So I'm going to take the existing collision stuff folder and delete it, and then I'm going to go and replace it with and if you drag and drop the collisions test.yyMPS into the GameMaker IDE, it'll automatically prompt you to import it. So let's go and import the new collision stuff assets, and that's going to add both the updated scripts where those have changed, and also some things such as call world and SAT stuff that's been newly added. I'm going to call that a day. If I run the game now, it should be functionally identical to what it was before. All right down to performance, and the old collision shapes still work. All right, that's a good sign. There's no old things have broken. So a recap for how collisions were implemented in this project. It's pretty much all in the step event. It does it in 3 places. One, when the player moves, it checks for collision on the x-axis. It loops through all the trees in the game, checks for collisions on the x-axis. And then again, it does it on the y-axis, so it checks for the player's movement on the y-axis, and then it does it a 3rd time on the z-axis when you're jumping up and down. And as we can see, it works, it produces the correct result, but it's, one, it's kind of a pain in the neck to write this code to have to loop through every object in the world every single time you want to check a collision. And 2, it's a bit of a brute force approach that's not super efficient, and we can make it more efficient. So first, let's instantiate ourselves a little collision world. I'm going to do that right here at the top. I'm going to say collision world is going to equal a new call world. This takes 3 arguments. This is going to take a bounds min, which is going to be a vector 3. I'm going to mostly arbitrarily say new vector 3. Let's go with -2000, -2000, and why not? -2000 on the z, even though most of the things in this game are pretty much on the same plane. The bounds max, so the maximum bounds of the world that the collision volume is looking at, is going to be same thing, but in the positive direction. New vector 3, 2000, 2000, 2000, and the max depth, let's make that 3. So the max the max number of subdivisions that each cell in the collision world can occupy. Actually, you know what? Let's make that more like, let's go a little deeper. This is a big world. We can afford to make it 4 instead. So now that the collision world is initialized, we might as well start adding stuff to it. So the two types of 3D objects in this world, I'm going to actually, I think there's 3 types of 3D objects in this world. There's the floor, there are the trees, and then there's the player. So each of these types of shapes, oh, I guess there's the ball too, which I'll get to later. Each of these types of like game entities contains their own collision shape, which is either an ab or a plane or a sphere, or the ball is just a point that we're going to be raycasting from later. And to get these into the collision world, we are going to want to say collision world.add, and we're going to add ourselves an object, and this is going to be a new call object. The collision object, as you know, takes a few parameters, one being the shape, so the actual collision shape, spheres, boxes, whatever, and that is going to be, why did I decide to just like doorbell? Alright, whatever. Why did I decide to like store the floor object in the array of trees? That seems a little bit silly. Anyway, the shape is going to be the floor.shape. The reference, so the object that we're going to refer back to with the thing in the game that this collision object is going to refer back to is going to just be the actual floor itself. And am I missing a parenthesis somewhere? I am. Very nice. And then when we instantiate each and every one of these trees, we can do basically the same thing. Collision world.add a new call object. The shape that we're going to add is going to be tree.shape, because remember, each of these tree objects have a collision shape as well, and the object that is going to refer back to, the entity that's going to refer back to, is the tree itself. Next, even though it's not going to be part of the collision world, although you could add it if you want to, because remember, objects don't collide with themselves, the player is going to need a collision object. I'm going to just like player.object. GameMaker allows you to tack on variables onto things after, like, outside the constructor, so I'm gonna take advantage of that power. Player.object is going to equal new call object. The shape is going to be player.shape, and the object reference, the entity reference, whatever you want to call it, is going to be the player. So this is all the setup we need. Let's go over to the step event, and now we can, instead of looping through all the trees and checking all the trees one by one for collision, we can say if obj underscore camera dot collision world dot check object. And remember, this code is running in the scope of the player here. So if we are detecting a collision between the collision world and the self.object, so our own collision object, then, and this is just going to take the place of the big ugly for loop over here, because it's going to do all the collision checking ourselves. Then we can just set dx equal to 0. And we don't need a break over there. Dx is the movement in the horizontal axis. On the x-axis, the terminology is a little bit stolen from calculus, but not too much. Hopefully nobody minds. And then we can do the same thing on the y-axis, so we can say when we check our potential movement on the y-axis, if the main game object's collision world.check object ourselves, if a collision is detected on the y-axis, then we won't move. And on the z-axis, it's going to be similar, but instead of saying like dz equals whatever equals 0, it's going to actually be z speed, because that is a persistent movement value, and that it accumulates over time because gravity. So now here's the moment of truth. If I run the game, we should have something that works just as it did before, and so far it does, but it performs much, much better. All right, cool. I got this working on the first try. It does not always happen when you're recording a video or a Let's Play or whatever. Alright, so if I hit, I believe it's the tab key, what is it, the Z key? We can see okay, tab was to unlock the mouse. If you hit the Z key, you can show the collision shapes. And you can see that each of the trees is where their colliders are. You can see where the player's collider is, and you can see where things are getting stuck and not being able to walk through the trees. And you can see now that the FPS real has gone from, what was it before, like 40 to 50 range to 200 to 300 range.
Hey.
And that's definitely quite an improvement. If I do the little jump thing, oh, I can, like, I'm not checking when I'm jumping to see if I'm actually on the floor, so I can just sort of fly here. Movement on the z-axis is respected as well, so you can jump on top of trees, you can fall, and you can stop when you hit the ground. There's nothing special that prevents you from going below the floor, except for the fact that the floor's collider is there. Okay? Alright. So, much more efficient, and the code to implement it is actually quite a bit nicer, which I think is a win for everybody involved. Alright, what next? Next, I'm going to deal with the ball raycast, so that we can raycast into the world. But first, when I go into the 3D collision test world, and now let me look at the where are we? Objects. Let me look at the ball's code. So, the ball is kind of a mini object. It has an update method. The ball has a step event, more or less. It's called update. The ball object itself is pretty simple. It has a position and a direction when it's instantiated, and then in the step event, all that happens is that it adds its direction, its velocity vector, essentially to its position, and that's it. It doesn't check for collision or anything. It has a collision shape, which is a point, and now that I think about it, I'm pretty sure I'm not actually using that. The demo world should work exactly the same with or without the ball's collision shape. So I'm just going to take that out for the sake of simplicity. So instead of doing this, let us go and do a little raycast. So I can say, let's create ourselves a ray. This is going to be the ray that represents where the ball is moving. The origin is just going to be the ball's position, so that is going to be self.position. The direction is going to be, well, now that I think about it, the ball itself shares quite a bit in common with a ray, doesn't it? It's just a point in space with a velocity, which is the same data structure as a direction. So I'm going to get rid of, actually, I won't get rid of that yet. I'll just comment it out. So do I have it open already? I do not. The world's check ray method, you may recall, instead of taking a hit info as an input parameter to the function call, to the method call, it's going to just create one on its own, and then it's going to return that if a hit was detected, and then it's going to return undefined if no hit was detected. So instead of having to say something like var hit info equals new raycast hit information or whatever, and then do that whole song and dance, we can just say var raycast result is going to equal obj obj demo. Is that even in this project? Oh, that's it's a variable that's referenced somewhere. If I was using one of the newer GameMaker betas with the Feather IntelliSense, it would probably give me a little bit of encouragement to remove that variable wherever it happens to be. Anyway, obj camera.collision world.check ray, and we're going to test this ray against the entire collision world, and we can say if raycast result is not equal to undefined, else. So if the raycast hits something, we can say if raycast result.distance, which is the distance between the ray's origin and the nearest hit location, if this is less than self.direction.magnitude, then self.position is going to be raycast results.point. And then we can just, we can set our direction or velocity to 0. So self.direction is going to equal new vector 3 with a 0 on all of its components. Else, if the raycast in the direction of the ball's movement does hit something, but it is farther away than the distance that the ball should move in this current step, we can just we can continue on our merry way and worry about stopping when we hit something later. And then, of course, if the raycast result is equal to undefined, so if the raycast doesn't hit anything, we can also just continue on our merry way. Alright, so now when I run the game, we should see I'm going to go and throw the ball, and it's going to stick to the tree's collider. If I were to turn on colliders, you could see exactly where that lands. Alright, if I were to throw the ball somewhere like off into space, off in that general direction, it's just going to keep going to infinity until I throw another one, and the ball's position is basically reset, like that. If I were to, can I try and like aim right at the corner? It's a little bit difficult actually when the colliders are turned on, because I can't see where exactly I'm throwing. Yeah, you can see that if we throw the ball right at the corner of that collider, it's going to get stuck. If I throw it maybe a little bit higher, it's going to go off into infinity. It'll pass through the top of the tree because there is no collider up there, and it'll just keep going off into space to infinity and beyond. So that is raycasting against the world. There's one more thing, which is kind of the big thing that we spent this entire, like, last part of the 3D collision series doing, and that is collisions against triangle meshes. Let's see, I'm going to do a little bit more setup. First, I'm going to commit this, the raycast ball. The raycast ball detects raycast hits. That sounds really dumb. So I can load in a triangle mesh. So we have a couple of vertex buffers. We have like VB tree simple, VB tree cone, VB tree cone dark, whatever. I am going to do a little bit more. I'm just going to make a few changes to the test program so that I can actually get one of those in here. One of those is going to involve, let me look at my notes. All right, first when we actually draw the world. Okay, let me just copy and paste a little bit of code into this project, and this is going to be, I think the tree that I'll use for a test here is going to be tree plateau. In my test project for this, I used tree cone, but I think the plateau tree is a little bit more of an interesting shape and should provide a little bit more interesting collision behavior. So this is just, we're looping through the vertex data, and we are picking out each of the actual 3D position attributes of the vertex data, and we're just forming them into a triangle mesh, into an array of triangles. There's two buffer deletes here. That would cause an error, wouldn't it? If you don't mind me copying and pasting a second time, I'm going to just go down to the bottom of the where the trees are added to the collision world. I'm going to instantiate myself a new tree object. Again, the model which we can instantiate with can be a plateau style tree. Set its x position to 0, set its y position to 0, just to make things easy. Its shape can be a call mesh instead of an ab. We are going to array push onto tree objects tree mesh, and the call object should just take two parameters, so the shape and the object. Okay, now this is going to spawn the tree at, I believe, the same location that the player spawns at, so let me just offset the player spawns. Okay, that's already happening. I thought the player spawned at the world origin as well, but it's just, the player spawns a little ways away from the world origin. So if I were to run the game now, you would see that the game would take a couple moments to start. Is the setup here timed? It is not timed. Anyway, this tree is, I want to say, about 500 vertices. This tree that's looking very prominently in the middle of the game world, it's about 500 vertices. It being there on its own doesn't really affect the frame rate. If I were to get close to it, it would, depending on where in the tree I was trying to detect collisions with. Denser parts of the meshes would obviously be a little bit more expensive. But the collision mesh being in the game world itself isn't really that expensive. This is why, slight tangent, but you might have heard that the precise collision checks with GameMaker Sprite collision masks is very slow and expensive, and that's not really true for pretty much the same reason. GameMaker's built-in collision system uses something sort of like a quad tree. I think it's precisely a KD tree, which is partition space a little bit differently. And if two sprites, even if they have like precise collision mask set, if they're far away from each other in the game world, they will not go to the effort of doing expensive pixel perfect collision checks against each other, because the broad phase of the collision detection will discard collisions that have zero chance of overlapping. Anyway, as far as the raycast goes, you can see that if I were to throw the ball at, for example, the tree trunk, it would stick. If I were to throw the ball at, and my aim is really bad. Come on. I'm lined up with the tree trunk, right? There we go. If I were to throw the ball at, like, the ball doesn't originate at exactly the same place as the mouse cursor does, which is a little confusing. If I were to throw the ball at the tree trunk, it would stick. If I were to throw the ball a little bit to the left or to the right, it would not. If I really had good aim, can I, like... There we go. I was trying to do that when I was practicing, like when I made this demo last night, and it was really hard to actually get the ball to hit the tree without being right in front of it, because my aim is that bad. If I aim at the branches, the ball will stick, but if I aim, for example, slightly below or above the branches, the ball will keep going, and we have precise collisions happening with the raycast. Okay, so this system also works with 3D meshes, and all is well in the world. All right, how long have I been recording this? Hopefully it'll be a little bit shorter than the video in which I actually set up the collision world, because that one was a monster. Editing that one sucked. All right. So I'm going to commit this. Let's see, this is just going to be a 3D mesh collision demo. That's all the changes I'm going to make here. I think there is going to be one more video in, like, Act 2, like an epilogue to this part of the 3D collision series. And that is going to be, I mentioned a few times, assigning collision masks to objects so that you can filter collisions and have only certain objects collide with certain other objects. And I decided against doing that, like, now as part of this video because I thought it would be a bit much. And it wasn't really related to the main point, but I do want to do it before I take, like, another 3-month break from 3D collisions, so there's probably going to be that. And then after that, I will most likely take another break from 3D collisions, and I think we are going to start dealing with matrices and rotations and other transformations in space, as well as rotated objects, rotated bounding boxes, things like that. I do want to talk about capsules. Capsules are generally pretty important in the world of 3D collisions, and I have not really talked about them yet, because they're a better approximation of things like the player character and NPCs than just a sphere or a rectangular prism would be. I also want to talk about other collision hierarchies that you might want to use. The way that collision objects are distributed, or even their specific use case in your collision world, can mean that certain types of hierarchies are better than others. For different situations. For example, one of the weaknesses of Octrees is that if you have a very dense collision world, you tend to see diminishing returns over just having a list of objects, because multiple collision objects can end up in the same, like, cell of the Octree, the same node of the Octree, which is not ideal. 3D terrain, because I just have a weird obsession with 3D terrain, is kind of its own thing. You can occasionally make some assumptions about 3D terrain that would allow you to add some terrain-specific optimizations. I'm trying to think if there's anything else I want to talk about. Best practices, I guess, or at least, like, my recommended practices when it comes to doing 3D collision worlds or something that could be fun. There's also the matter of, and this is a very dangerous subject, but implementing micro-optimizations, as some might call them, in your GML to make it faster without, like, changing the math, but just doing more efficient GML operations. That could be fun. I'm tempted to make a video on that, but I also don't want to, like, accidentally incur a new wave of people who are trying to micro-optimize their code instead of actually improving their algorithms, but that sounds like a problem for future me, which also happens to be my favorite kind of problem. So, my name is Michael. I like wizards and dragons and making games. This has been 3D Collisions in GameMaker. If you want the code for this, look for the GitHub repository down in the video description. Look for the, I guess, 0.2. on this test world, and I want to say the main 3D collisions project is like 0.19 right now. Working out of multiple GitHub repositories in a single video is confusing. I have a Patreon, so if you want to contribute towards these videos being made, look for the links to that in all the usual places. You can see some fun things like your name in the credits. About once a month I make a post regarding future plans for future video subjects. And if you wanted to pledge, I would definitely appreciate it. Otherwise, I try to post about 2 game dev videos a week, one tutorial like this, and one let's make a game. Currently Bullet Hell. I hope you all found this useful and interesting and fun, and you can all now go and create your own 3D platformers in GameMaker, and I will see you all later. Special thanks to Zenjamin, Then Nothing Happened, Squarecrow, Sindra Larson, Posho, Gunnar Clovis, GameMaker, Emily Koyo, Edward Holt, DJ Gibbles, and Army Umbrester for supporting these videos. If you want to see your name in the credits or hear yourself shouted out at the end like this, head on over to the Patreon page down in the video description to join the fun.